Hello, everyone. My name is Aaron. Thank you very much for coming to the talk. As Kofi mentioned, I work at Fastly on the WebAssembly team, but that's a slide of mine. So let's pretend like I didn't say that and get right into it. Let me share my screen. There we go. Now, can you see my screen? Anyone? Just quick thumbs up. Anyone on video? Cool. Thank you. All right. So here we go. WebAssembly at the edge. And, I added some skateboarding because I thought it was edgy. I thought that'd be pretty funny. Have a little pun. So here we go. So who am I? Like an owl. Who? Haha, that's a joke. Funny. We're already on it. Okay, my name is Aaron Turner. I go by Torch2424 on the internet. It's super random. You can ask me on Twitter at some point if you're curious why. And here are a few things about me. I do a lot of things, so I'm just going to run through them real quick because we cover some of them in the talk. But I'm a member of the AssemblyScript team, which is a TypeScript-like language that compiles to WebAssembly. No, it sounds like, oh, that sounds really interesting, but we'll get into it in a little bit. I created Wasm Boy, which is a Game Boy emulation library written in AssemblyScript to compile to WebAssembly. I made a thing called Wasm by example, which is like bite-sized, like quick examples for learning how to use WebAssembly in your applications and things. I made Wade with WebAssembly. So if you learn how to use WebAssembly and now you're like, what should I make? It's like a showcase of projects to like kind of show how people are using WebAssembly and how it helped them. And then I work, like I mentioned, at Fastly at their WebAssembly team efforts thing. So what are we talking about today? I've already said WebAssembly a billion times. We're probably going to be talking about WebAssembly a little bit more. So we're talking about WebAssembly, also known as Wasm. It's relatively new. Essentially, it's a portable binary format that runs on the web, both in the browser and the server. And we'll talk about its relation to JavaScript a little bit. And we'll also be taking a look at Wazi, which is a system interface for WebAssembly. Then we'll be talking about the edge and not skateboarding. I mean, skateboarding would be cool too, but specifically in terms of edge computing and how it differs from traditional distributed computing. And then we'll be combining the two. Why do we think WebAssembly and the edge could work together, and kind of exploring that space a little bit? And then we'll be closing things out with how WebAssembly is being brought to the edge through combined community efforts like standards to make a better WebAssembly for everyone. So first, what is WebAssembly? This picture is from Wasm Summit, which is the first WebAssembly conference that just happened a couple months ago. And it's the first WebAssembly conference ever. So that was super exciting. What WebAssembly is, like we briefly mentioned, was a universal low-level bytecode on the web. So, because of this, just giving some examples, WebAssembly is really good for running logic-heavy tasks compared to something like JavaScript. That means it's good for image manipulation, physics for games, and heavy math computations. But why would it be great for this? The reason is WebAssembly offers predictable performance. JavaScript needs to be parsed, evaluated, and then compiled many times in a just-in-time compiler. And this can get extremely fast because it makes the right optimizations or fall off this fast path when it makes some mistakes. So bytecode offers a more consistently predictable performance that won't fall off this fast path. Wasm's current state runs a lot of its bytecode without interpretation, like we just mentioned. So you get that benefit compared to something like JavaScript. One more thing is that WebAssembly is extremely portable. So it runs in all major browsers. They all ship WebAssembly today. So I looked on Can I Use, and that was about 93% of all browser users can run WebAssembly in their browser. Runs in Node, so you can take your same image transformation that compiles WebAssembly and run it both in the client and the server, which we'll kind of explore a little idea there later. There's a lot of standalone WebAssembly runtimes like Lessontime and Lucid, which we'll cover. There's Wazi, like we're going to get into in a little bit, which is the system interface with WebAssembly, and is very bundleable, if that's a word. But essentially, I'm trying to say it's great to throw into NPM and put into packages and things. And there's a lot of languages right now that output Wasm, more on this portability front. So the most mature three are AssemblyScript, which is that TypeScript-like language that compiles WebAssembly that I'm on the team for. And when I say TypeScript-like, what I mean is that you can't just take a React app that's written in TypeScript and just compile it to WebAssembly for free. But what it does offer is offers really nice tooling like Aspect, the testing library. It's very similar to Jest. You can still install through NPM, and it has a very, very similar syntax. Like, for example, probably the biggest thing you'll notice that like in terms of syntax differences is that there's no number type, but instead you have to be even stricter and use like an I32. So a number integer of 32 bits, but you get the point. So it's very similar. We'll look at it. Yeah, we'll look at it a little bit. But another one is Rust, which is also a very popular WebAssembly language. It's very mature, has some amazing tooling, especially for the browser. So if you like Rust, that's good for you. And then there's Scripting, which is a toolchain for C. It's extremely mature because it evolved from the precursor to WebAssembly, which is Asm.js, just a super hyper-optimized JavaScript. And what it does, it takes C and C++ and compiles that to WebAssembly. So another thing about WebAssembly is that it has this concept of linear memory, meaning it's kind of like you get this big old single heap or array that you can write to on both the JavaScript and the WebAssembly side, or your host and guest. Well, guest being the WebAssembly, your host being JavaScript in this browser case I'm explaining. But this is great for things like security because it makes it really easy to sandbox this memory. So that way multiple Wasm modules won't write over each other's memory and you don't have to worry about things like that. And another thing is WebAssembly relies on a capability-based system of security and stuff. So I know I'm saying and stuff, but an example to explain the stuff is that a host would provide access to imported functions. So like, let's say you wanted to call maybe some type of JavaScript function that you can give pretty much a reference to it through the host when you instantiate your WebAssembly module, and then your WebAssembly can then call that from inside of the WebAssembly, which means WebAssembly will only have access to what the host provides it. It means you give it capabilities to do things other than just simple computation. So this is another great factor of security because then WebAssembly can only do what you tell it has access to do. So now that we covered a lot of the fundamentals about WebAssembly, what about this system interface for WebAssembly? WebAssembly System Interface, or WASI, is a standardized set of system calls or other operations that allows interacting with system resources, such as file systems, randomness, and time, and eventually networking devices as the spec evolves. Wazi can be implemented by a lot of these different standalone Wasm runtimes I mentioned earlier. So browser runtimes like V8 don't implement Wazi because, again, that capability, browsers don't, as of now, don't want you to just mess around with the file system. But like I said, there's all these standalone ones like Lessontime and Lucid. And what these do is essentially just provide these access to these WebAssembly modules to mess with the file system and stuff that you have to explicitly grant it. But, it pretty much executes these commands on behalf of your Wasm module. So this is really cool because what you can have is these really performant small WebAssembly modules that are sandboxed by linear memory, only have access to what the host grants it, and it's all on top of this standardized set of system calls. So it's kind of like you get all these benefits of WebAssembly with all the controlled access of host and system calls. So we're going to put a pin in that, and now that we understand a bit about WebAssembly, what is the edge? In particular, what is edge computing? So the edge kind of represents just putting your servers closer to your users. Traditionally, you would have a handful of servers or data centers in like one space, and they'd be really big and they'd do a ton of computation. But light can only travel so fast from like when you make a request on your computer all the way to the data center and back. So if they're across the globe, then light can only get there so fast. So the idea of the edge is that to put a lot of smaller servers rather than like big data centers closer to your users. And the smaller servers do smaller tasks, like they'll do things like caching and just sending files here and there. But you can still use those larger servers for those big like database queries and things. So you only have to visit the database or go to your data center like half as often or however less often that you normally would, while still giving your users that speed because you have a closer server to them. So you get a really fast, consistent experience across the world. So Fastly specializes in the idea of the edge. What they have are these edge servers. They're called POPs, and they're all across the globe. Fastly has about 72 POPs that are very strategically placed. That way you get the best possible speed, like no matter where you are, essentially. And one thing about Fastly is that it's probably most well known for its CDN or content delivery network, primarily used for like caching, like I just mentioned earlier, but for things like images, videos, etc. The CDN currently allows for programming certain cache rules and things in our DSL called VCL, and using that you can fine tune how things are cached and hyper optimized. But one thing, you see a lot of distributed computing networks offering storage at scale like Fastly currently is, but it's also possible to use compute at well, these little POPs and things, these smaller servers. And this is kind of often known as like serverless. For example, those like one-off functions that get run when you call them for one little thing. And traditionally, traditionally serverless has been done on like someone else's origin servers, but the space is these original big servers. But now it's slowly starting to move towards the edge on these smaller computers, like I was mentioning. So Fastly started asking ourselves, how can we bring compute to the edge? So we wanted something that was really solid that takes advantage of the existing Fastly network that was mostly used for like all types of other content CDN type stuff. So we started thinking about, what are the things that Fastly and our customers want from a edge computing platform? So one would be language portability. We have a lot of customers that use different languages. We knew writing an implementation would be hard, but also we didn't want to exclude customers who didn't already use a language that we chose to choose. Security, definitely a super huge one. We're running untrusted code for the most part. So the solution needs to be able to keep our customers safe from one another or bad actors that will sign up and try to abuse the platform. Runtime performance. So as the nature of the edge, we want to make sure things are fast, like, things currently are just, generally we want things to be fast because kind of edges on that idea. So this, whatever solution we come up with, these one-off functions need to be able to run really fast. Memory usage, we want to conserve our resources. Less resource usage puts less cost on us and our customers. So we don't want to use resources on things we're not always using. And then cold start times. So probably one of the biggest things we hear in the serverless space is, the big downside is cold start times. So what is a cold start? It's whenever a function or resource has to be fetched and reinstantiated on a server. So like, if you're maybe in London and you're using a function, it's like hot, it's already in memory, but then someone from Australia maybe starts using it. So then they need to fetch it from all the way over there, instantiate it, and then you can use it in this area. So that's cold whenever it's not already in memory, it needs to be running stuff. So, this takes a lot of time. You can make the requests much slower. And there's a lot of public work done on minimizing these cold starts. And there's a really nice paper from the Azure team on this that I recently read. But we also want to minimize cold starts, if not eliminate them. So we don't want customers to have to pay and ping an edge server to keep it warm. And these keep warm functions you'll often see in the space. So first question we ask ourselves, let's look at some options. The first option we probably came across was containers. We could ask customers, hey, just throw a Docker container. We could put restrictions on it. This would give us that great language portability and that security. But, this isn't great because the cold starts would be super slow trying to boot an entire container every time it wasn't in memory. And the memory usage would be really quite large because it would be whatever their application was, plus essentially all the operating system related stuff that may or may not being used by that single application that has to also get booted up and loaded into memory. So then we thought, okay, maybe JavaScript, it's only a single language, but it's a really wide net of a language. And technically JavaScript V8 supports Wasm too, but you have to run through JavaScript first to then instantiate the Wasm. But so, we just thought about V8. Security would be great with the V8 isolates, and memory usage would be very acceptable because it's just a language runtime. It's not an entire operating system, essentially like a container is. But it's still quite not there because cold starts would still be unfavorable, having to reinstantiate V8 every time. And V8 is super fast, but like we mentioned before, JavaScript's interpreted, so that runtime could really suffer, depending on how things get just in time compiled. And again, only JavaScript would be supported, so every developer would have to touch JavaScript in some way to use our platform, and we were trying to avoid having to force a language on our customers or developers. So here comes the punchline. Let's dive into why WebAssembly is great for the edge. So language portability, like we mentioned, many languages compile to WebAssembly. That means any language that compiles to WebAssembly could technically be supported by a WebAssembly runtime, or platform. So all we need to do is provide a very slim SDK for each language. That way we have a convenient way of using the platform, and then we'd be good to go. Security, like we mentioned, WebAssembly has that linear memory, that sandbox, continuous heap. That's really cool. And you can't access outside a sandbox, which is perfect for that untrusted code and abuse that we were talking about, but also that capability-based model that we mentioned. So like we said, WebAssembly without capabilities can only do basic logic and access its own linear memory. So with this capability-based model, we have explicit control on what our guests or customers are able to run on our platform. And we can also grant them special things that are specific to our platform, whatever it may be. And again, this is great security for our use case of running untrusted code. Next, runtime performance would be really good. Every use case and benchmark is different. So, take this with a big grain of salt. But in general, Wasm is about 30% slower than like natively compiling through like something like a C compiler. Very much depends on what your use case and what your benchmark is. So there is some performance loss, but very little and much better compared to alternative solutions we were looking at. So that's really exciting. Memory usage would be really excellent because Wasm modules are extremely small. Like for example, an assembly script, hello world, can fit in about 55 bytes. That's the smallest I've been able to get it. And not like kilobyte, just the word bytes. So, But also using one of those standalone runtimes, the standalone Wasm runtimes, they don't need an entire OS to boot up every single time like a container, and they don't need to ship an extra runtime, would for example, V8 ships JavaScript and WebAssembly. If we just ship WebAssembly, we don't have to also ship JavaScript whenever we boot something up. So very slim, very little memory usage. And cold start times, cold start times could be drastically improved with WebAssembly. There's much less bootstrapping of a container or JavaScript like we just mentioned, and we only have to make an instance of the standalone Wasm runtime and then immediately start executing. So once we get that runtime running, like we're good to go. We don't have to worry about some other dependency to start getting ready to go. Like it's just already there. We can start going. So, these are all really great technical reasons why Wasm is good for the edge, but I also want to take a step back and imagine a quick example where this can all come into play. So let's say we have a large group of users. They have a lot of slow and old devices, but their internet's like pretty decent. And that, for example, this use case could, or not use case, but this user base could be someone like a low income user in a big city. So the internet's pretty decent, but they just don't have enough funds to get like the new Apple iPhone. I think 12 just came out. So yeah. So, that's kind of the situation we have here. And we have this operation that's, in the browser written in JavaScript. Or we have this operation that's, let's say it's written in like C, so it can't run on the web. And we're constantly having to pull our data center because it's very unfeed. Like, we're pulling the server because the network speed's okay, but it's just, kind of long to go across the country and things. So, we kind of can imagine this use case. And this is where WebAssembly could be a great fit for that. For those powerful devices, for the users in the city that do have the iPhone 12, what we can do is take that server code we used to pull, compile it to Wasm, and get it to run on the client. That way, it's instant, it's running in the client, and WebAssembly brings that other language to the browser, and we don't have to worry about slow network calls. But for the less powerful devices that kind of do still need to do a network call because their CPU just can't handle running this huge operation, we can compile that same code to Wasm again, and then run it on the edge. That way, we're not hogging CPU, but also we have a lot less latency on those network calls because it's so much closer to our users. And one example I want to highlight of this, where it's kind of this idea of using the client and the server. Esri is a mapping project company thing where they map the world and stuff. And they have this demo essentially where specifically, if they notice that your device is powerful enough to run the operation in the browser, it does it there. But if it notices that it's kind of slow, it'll run it on a server. So that way your performance is always really good. They aren't using the edge because our platform right now isn't out all the way yet. We're still in beta, but you can imagine this case where the edge could come into play here and it would provide another really good use case. So taking a look at all these reasons, like WebAssembly seems like a great fit for the edge. In that real world example, that could probably be used in your tech stack. You can maybe even start to think like, oh yeah, we do have this user base, or like, oh, this one thing could be a little bit faster if brought it closer, no matter what language I'm using and stuff. So yeah, WebAssembly seems like a really good solution to this problem. So let's go ahead and start bringing WebAssembly to the edge. We identified it's really cool and it's a really great place that the edge could excel with. So yeah. So WebAssembly, I will admit, is very new and has a really long to-do list, meaning there's still a lot of work that needs to be done. And there's a lot of things that kind of are second nature that we just use every day that might be missing because, someone hasn't built it yet. So thankfully, there is an amazing community that's driving WebAssembly. There's a lot of organizations and individuals that see a lot of value in Wasm, including Fastly, and are investing resources to make it awesome. And when I say amazing, I mean like amazingly smart, but also amazingly nice and welcoming people to be around. So first thing I'd like to highlight is the Wazi spec, or the system interface I kept mentioning. The Wazi spec is led by Dan Goman. This is the repo, that's, my screen's over here. I just realized I'm pointing over here. Yeah, this is the repo that contains all the information on the Wazi spec and stuff. And it's where PRs are made. So that way, if you ever want to change the specification, you open a PR and you can propose new changes to the specification. And Wazi's been steadily accomplishing new things. So WidX is championed by Pat Hickey, who's a colleague of mine, which is a language for defining different interfaces in Wazi. Wazi has a snapshot process for versioning. So that way, if you're on an older snapshot, you can upgrade gracefully over time. And they have lots of cool proposals in the pipeline. Like I was in a Wazi meeting recently, maybe about a month ago, and someone was proposing a system interface for machine learning. Where I was like, oh, that's really interesting that, we could build an interface on top of general machine learning that people wanted to use in WebAssembly modules. So that was really cool. And another proposal I'd like to highlight is the crypto proposal. So Frank Dennis is another colleague of mine, and they're championing this. And this would be super useful because I have a lot of friends that happen to be in the Wasm blockchain space. And one of the first things they kind of bring up about WebAssembly is oh, dude, I really need access to crypto. So having it standardized that way, a lot of these different players that are really wanting crypto right now can all share that same interface is going to be really exciting, and having it standardized would be really cool. So next, we can cover some of those standalone runtimes I mentioned. Lessontime is a popular choice for a general WebAssembly runtime. It was started by Mozilla, and it's focused on being lightweight and fast. And what it uses is CraneLift to generate machine code at runtime, and it also follows the WebAssembly and WebAssembly system interface, or Wazi spec, very closely. So the updates come pretty much almost as soon as they land. And another one is Lucid. Lucid is built by Fastly, and we will be using this for our edge computing. The reason why it's a little bit notable is because Lucid uses an ahead of time compiler to compile its WebAssembly modules to get them running. So Lucid is more if you need ahead of time. Otherwise, we generally recommend use Wasm for your more general like server-side WebAssembly usage. But something I'd like to highlight here is the performance of Lucid. So Adam Folzer is a colleague of mine, and they ran some benchmarks on Lucid and the performance, and Fastly released a blog about it. And the most impressive thing that we got from this is that from the benchmark showed that a Lucid could instantiate a Wasm Hello World in about 52 microseconds. And yes, microseconds, not milliseconds, so like extremely fast. So we talked about those cold starts earlier. They would be extremely minimal for what we were trying to shoot for. I'm really excited about that. So next, I want to highlight some of the languages that compile to WebAssembly. So, we mentioned earlier, Rust has been super strong in the toolchain for the Wasm space since the beginning. Rust is continuing to see investment from multiple companies outputting WebAssembly. For example, Rust has really good Wazi support, and it's continuing to see crates and projects that are rewritten or ported over to support WebAssembly as well as a compilation target. So that's super exciting to see that the community is really behind it. And then again, I'm on the AssemblyScript team, so let me put on my AssemblyScript hat. It's the language that I've been on the team on for about 2.5 years now. And we've been seeing a lot of new investments from people like Fastly and Shopify. The language is still really young, and we've continued to improve our UX and developer experience. But we have a really good JavaScript WebAssembly interop story now. So if you want to use it in the browser, transferring high-level data types and stuff is getting a lot better. Another big feature of AssemblyScript that we're still working on is closures. So passing functions around can be a little funny. They work for the pure functions work, but accessing closures gets kind of funny. But we're getting really close. Shopify has done a huge investments in that. And then after closures, regex is probably our last big hurdle. But otherwise, for the most part, it's it works. And I hear great stuff about AssemblyScript all the time from users. So yeah. And we've been having bi-weekly meetings as a community, and those have been going really great to see people's projects and talk about the compiler and ways we can improve things and stuff. And so yeah, and more experiments. So putting my Fastly hat back on, I've been helping languages and their ecosystems in general come over to Compute@Edge. AssemblyScript is something that Fastly is now supporting in our beta. If you happen to be a part of it, my status as a team member helps because then we can be like, hey, AssemblyScript team, we're gonna launch this thing, and they're like, cool, let us help you out or stuff like that. But we've also been experimenting with languages like Go. Go is still very young in its Wasm days, but it's something we're exploring, and we've been spending a lot of time talking to the Tiny Go folks to see how that's going to go. And we've been playing with languages that don't compile to WebAssembly, because if a language can compile to WebAssembly, maybe its runtime can. So what we did is that we compiled the Quick.js runtime, which is a JavaScript ES6 runtime, to WebAssembly, and we're doing some experiments there. So even though we mentioned about how we might not support JavaScript, that's something we're still exploring to see if we can compile a JavaScript runtime to WebAssembly to then run JavaScript, which is kind of funny, but yeah. And most importantly, I'd want to highlight the WebAssembly community. There's a lot more than just code that goes into building software on the web, and the community is probably the most important part of it. So first, I like to highlight the Bytecode Alliance. I'm sorry, whenever I talk, my mouth gets dry and then I get stuck. So it's hella funny. But it's a group of companies that want to invest in WebAssembly and Wazi. So for example, Mozilla, Fastly, Intel, and Red Hat. And we've all been working together to help bring a shared vision of what we'd like to see in WebAssembly, which is a secure by default WebAssembly plus Wazi, which would greatly help in running untrusted code. So we've all had this shared, it'd be cool if we could run untrusted code with WebAssembly and stuff, vision. Next, I'd like to highlight WebAssembly SF. It's run by Jonathan Barry. It's a monthly meetup in San Francisco. It's been on hold, on and off. They've been doing virtual ones due to current events, but it's a great place to stay on top of all the cool things happening in WebAssembly. Made a ton of friends there, and great projects are always highlighted there. And thankfully, all the talks are recorded. So there's a YouTube channel that I think is a huge wealth of knowledge about WebAssembly. So if you're interested in the WebAssembly space and you like watching talks like this one, then I'd highly recommend that you check that out. And the next is Wasm Summit. It was the world's first WebAssembly conference. It happened around February of 2019 that, I helped organize it with some notable friends of mine, such as Surma, Ashley Williams, myself, and a lot of other amazing organizers. There's a lot of us. I don't want to list them all, but those are some of them. And again, all the talks here were also recorded. So if you're interested in WebAssembly, there's a huge wealth of knowledge here by a lot of the most notable of people and teams driving WebAssembly currently. So yeah, this is another amazing resource. I'd highly recommend it. And one side note real quick is that this is the first time I think the entire WebAssembly community had a chance to meet. So it was super memorable for me, and the entire event was a blast. I remember so many people were like staying late, like just trying to like hold on to like, dude, let's grab dinner, like let's talk about this. So it was a lot of fun. And there are so many other cool projects and spaces for WebAssembly. If you watch this talk, you might already be thinking like, oh, WebAssembly could, maybe it's good for that or good for this. And a lot of people have identified great places for it, such as IoT. Wasm 3 is a interpreter for WebAssembly for like, it's really small, which makes it great for IoT. Jonathan from Wasm SF that I just mentioned, they had a great talk at Wasm Summit on IoT and Wasm. So it was like, the both of the things I just mentioned came together for this IoT WebAssembly talk, which is cool. WebAssembly in the browser is getting a lot better. There's the thread proposal, which I think is just about to land in Chrome if it hasn't already. And there's new projects popping up that use WebAssembly every day. The newest one I saw is that someone compiled FFmpeg, like the video encoder, to WebAssembly. So now you can like just encode files in your browser essentially, like without having to like do anything. It's not the fastest, but like it works. So you don't have to like worry about a server holding your video for ransom or something you're worried about. But yeah, and also game development. So you might have seen like, oh, this is probably great for games, and indeed it is. There's a lot of game engines that are adopting WebAssembly backends like Unity, Godot, and being on the AS team or the AssemblyScript team, I've seen various smaller like web game engines start using AssemblyScript to do some things like bullet physics and stuff. So that's been really exciting. So one point I really want to drive is the tech behind Wasm is why I got into it, but the WebAssembly community is why I'm so stoked to work on it every day. If you have ideas or if you're part of an organization, you can be part of it too. Everything's open source for the most part. For example, as an AssemblyScript member, I didn't meet with Shopify and learn about how they were using WebAssembly and AssemblyScript until we chatted at Wasm Summit. And since then, they've been an awesome help to the project, and they quickly got some PRs in to fix bugs that they had with AssemblyScript and things that they wanted, as well as Duncan from Shop. They're someone we work with all the time from Shopify, and they and I have been working closely on that closure thing I was mentioning we're working through, which is in turn building a better WebAssembly for everyone, because now we can all benefit from it. And with that, let's wrap things up. So here are my main points. Normally I'd say take a picture of the slide if you like taking a picture of the slide, but now you can screenshot. So if that's what you want to do. But yeah, I'm just joking around. But WebAssembly is super exciting. It's super cool tech that opens a lot of doors on a lot of different spaces. So that's really cool. One of those spaces being the edge. It's an exciting space for compute. It can solve a lot of different problems and drastically improve user experience, I think. And I think WebAssembly can be a key part of that implementation. The WebAssembly community is awesome. It's awesome people making awesome WebAssembly. So like the personalities as well, I think. But and yeah, we're all building it, standardizing it for all these different use cases and applications. So thank you very much. I really appreciate your time. I want to give a big shout out to my team at Fastly, Katie, Adam, Pat, Tanya, Andy, Tyler, Aaron, because we have 2 Aarons now. And we had a bunch of new folks that just joined. So I want to thank them as well. I'm really happy to get to work with all these people every day. Thank you, conference organizers, for having me. Thank you, Kofi, for the introduction. And thank you for watching. Please feel free to reach out to me on Twitter. I have my name on here. And thank you very much. Enjoy the conference. And with that, I think I'm done. Yeah. I'm happy to answer any questions.
Cool. Thanks, Aaron. Yeah. I don't see any questions in Huva. Feel free to post them there if anyone has any. Does anyone want to unmute and ask an impromptu question? If not, I have some, but keep thinking, folks, and type them in Huva if you have them. How did you get into like exploring Wasm originally, and was that like because of your work at Fastly, or did you get involved in Fastly because of your work with AssemblyScript? I'm curious about like the ordering there.
Yeah, so man, I could tell a whole ramble about this, but the quickest way to describe it is that I went to some conference and my friend was like, "Yo, man, have you heard of this WebAssembly thing? It's like assembly for the web." And I was like, "What?" And I don't know, personally, as a JavaScript developer previously, I always want to build things like I want to build a video editor in the browser, but it just didn't work because JavaScript's interpreted. It just wasn't fast enough. So when I heard about WebAssembly, I was like, "Oh, I need to be doing that." So I think it got standardized into all browsers, or I guess shipped in 2017. So like the second it was in all browsers, I was like, cool, let me just start building stuff. So I built a Wasm Boy, which is that Game Boy emulation library. And then from there, just started hanging out with the community more. Just, life, the way it works. I ended up moving to Silicon Valley for a little bit. And then I was just walking around like, hey, I have this WebAssembly thing. And people were like, yo, that's cool. And then one thing led to another. And I built the emulator at like my last year of college. So it was just like me at 3 a.m, like writing out opcodes and stuff. So I just got into it because I just really always wanted something like WebAssembly, and when it existed, I was like, yes, that's it. That's the one. So
that's cool. I'm still fuzzy, I think, on the distinction of like where Wasm ends and where Wazi starts, and in particular, I think I'm missing like how the secure by default nature fits into the goal of Wazi. Like, will browsers ever adopt Wazi because of the conflicting goals there?
yeah, so that's actually a really good question. So I guess the first part is, where does Wasm start and Wazi start? So Wasm really is just, for the most part, like your really basic computation. So like if you want to add two numbers, you want to write to memory, like that sandbox to memory, or you want to like do a for loop. That's all WebAssembly can really do. And what Wazi is like I mentioned, that you can access these host call functions that like pretty much someone can provide to your Wasm module. Wazi is just a standardized set of those host call functions. So all the runtimes are like, hey, look, if you want to support Wazi, you have to offer a file descriptor right, and we all just agree upon that file descriptor right. So for like a runtime to support Wazi, has to do that. And what that can tell Wasm writers, the people building these modules, is that, hey, you're going to be running inside of Wazi, so you can expect to get this function, imported to you because you're in a Wazi environment. So it's just pretty much, yeah, I guess that interface is what you can guarantee to people, because you can only do that basic computation. And in terms of the browser, because I know browser has things like the file system API that are in Flux and things. So I could definitely imagine a future where, like, hey, look, if JavaScript gets granted the permission to file system, let me just import my WebAssembly module after that and give it access to Wazi. There's nothing stopping a browser from doing that, but because everything is so new, I think it's just another case of like, it's just not there yet, just because no one has taken the time, because so many things are still being built for it. So it's totally possible. So yeah.
Cool. And if you try to instantiate a Wasm module without giving it some permission that it expects, then is there like the capability to code within the Wasm module like degradation?
Yeah, I think there is. I don't know off the top of my head off how I would do it, but for example, like threads, for example, like I don't know if that's built into the WebAssembly spec, or I'm gonna say yes for now, but don't quote me on it. But
Sure.
I'm pretty sure there is. Yeah.
Right on. Cool.
Because I think it depends on the runtime too. Because I know, for example, like some runtimes like Lessontime will just break out and say, hey, look, I don't explicitly know that I was supposed to import something to you and it's not there. I'm just not gonna risk it. You know what I mean? And some Wasm runtimes are like, who cares? Like, as long as you're not like, not that they don't care, but like, if something expected FD right, and it'll just try to run it until it hits FD right and be like, hey, look, it just doesn't exist. So it's up to the runtime to decide, like, do I want to break at runtime or do I want to break on instantiation, essentially?
Yeah. Okay.
So, yeah.
Interesting. Cool. Let me ask one more time if anyone else has any questions or wants to unmute impromptu. Taking it as a no. My last question was around, you mentioned Made with Wasm, I think it was called, like a community showcase. What was like, do you have any like examples of like something that was like really surprising as a use case for Wasm, or like really impressive?
Yeah. Oh man, there's so many. I mean, it sounds lame, but one thing I'm super excited for personally, and it's not like a novel Wasm use case, but just so I do a lot of music in my free time as well. And when I was at JSConf, I saw Ableton there, and they were talking about like, oh, it'd be really cool if there was like an Ableton for the web, start making music in the browser entirely. Which to me, immediately I start thinking of like things like Google Docs, where I'm like, what if I could like work on a music project that like, because WebAssembly allows you to like add all these sound files in a way that's not like super slow, it becomes possible in the browser. And I'm like, well then, because we have WebSockets, then we could like pull the two together, and then we could have like collaborative music projects in the browser. So that's one thing I'm super hopeful for. And I know there's some like demos of music stuff that big DAWs have been doing in the music scene. So I'm like really excited for that.
Cool. We did get one question. This whoever asked it want to unmute themselves. Alexandros, I think.
Yes. I heard a talk from at one point saying that if WebAssembly had been around at the time when Steve Jobs was developing the first iPhone, that maybe they wouldn't have gone down the route that they've taken. So do you see JavaScript and WebAssembly at some point replacing Android and iOS apps?
Yeah, so I think I wouldn't necessarily say that web apps will beat native. So it's a really interesting discussion. I guess I'll take a step back and say what I see happening is I think WebAssembly is great for things like business logic. So let's say, for example, a good example of this actually live today is Google Earth. They recently did a really big rewrite. And what they did is they took all their like business logic behind Google Earth of like scrolling the map and stuff and compiled it to WebAssembly. And what they do then is build a really thin layer on the web. They build a really thin Android layer and a really thin iOS layer. So most of that code is running WebAssembly and just running a runtime in each of those small layers. And I think it's important to keep those native layers for whether it be web or native or whatever, because sometimes native will offer special features that just can't really standardize across every device ever. So I don't see them replacing one another. I think, WebAssembly could become like the backbone or the spine to each of them, but they're all going to probably still exist because they excel at certain things. And that's why we kind of choose each platform, if that makes sense.
Mm-hmm. Thank you.
At least I'm hopeful, because that would be really cool if I didn't have to like write the same, I don't know, squaring math function 20 times, whatever code you've written, But yeah, awesome. Thank you.